Okay, so we saw in that first example that we could evaluate the limit of a rational function by looking at the tangent line approximations for the numerator and denominator and then taking the ratio of those tangent line approximations. And when we did that, we saw that effectively what we're evaluating is the ratio of the derivatives of the function at the point that we're trying to find the limit at. So that gives you a taste of where L'Hopital's rule is coming from. I'm not going to go through a full-blown proof of L'Hopital's rule, but this is essentially what it says. It says that if you have two functions, f and g, where they're differential and also f prime of g is not equal to 0 near a, except possibly at a, okay, then, and if the limit of f and g are both 0, or the limit of f and g are both either plus and minus infinity, okay, then the limit of this rational function composed of f and g of x is equal to the limit of the derivatives of f and g of x. Okay, provided the limit exists. Okay, of course this limit here on the right hand side has to exist. This thing has to exist. All right. And a lot of times it just gets glossed over, and you know, you just think, okay, well, we could just do if we can't do the limits of a rational function, we just take the derivative of the numerator and denominator, and we can find the limit of that. But it's important that these conditions hold. Okay, one of these two conditions, either both the numerator and denominator are 0, or both the numerator and denominator go to infinity or minus infinity. Okay, so that's important when you apply this. So, okay, so that's what this first paragraph says here. Is just you have to verify those conditions, that either you have a 0 over 0 indeterminate form. We call those indeterminate forms. One indeterminate form is 0 over 0. The other indeterminate form is plus or minus infinity over plus or minus infinity. So you have to check that you have an indeterminate form. Okay? And then you can apply L'Hopital's rule. All right, so let's take a look at some examples. And I'll just go through example 2, and then I'll break it down so into individual videos. Now, you may want to watch one or two of these examples and then try the others on your own. You know, I just wanted to put in several different variations of how to apply L'Hopital's rule. Okay, so first thing we need to do, we're going to go through example 2 here. We first of all have to determine whether this is a proper indeterminate form. All right, so we're going to look at what happens as sine goes to 0. Well, sine of 0 is 0. Right? So, and what's the denominator as x goes to 0 is 0. So we have an indeterminate form. Indeterminate form. Okay, that's one of the indeterminate forms that L'Hopital's rule applies to. So we're good there. Now we can just look at the derivatives. All right, so we can actually evaluate this limit by looking at the limit as x goes to 0 of the derivatives of the numerator and denominator. So the derivative of the numerator is cosine of x. Derivative of the denominator is 1. Now, when we look at that limit, the cosine of 0 is 1, and of course the limit of 1 is 1, no matter what x value we're going to. So we have 1. So the limit here of sine x over x is 1.